Hello everyone, welcome to this video. My name is Emerson Ahari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to calculate number of frost days. This is one of the important climate indices that's used for extreme data analysis. There is a website on the net. It is ClimeDex, actually climedex.org. As you can see in this address, all of the indices related to climate extreme analysis available, and I'm gonna actually show you how to calculate number of frost days in this tutorial. I'm trying to make different tutorials for all of these indices because that could be very useful things for the all the studies and investigations in which interaction between climate and phenomena on the Earth's surface is matter. So back to the code editor Earth Engine environment, and now I'm going to show you how to calculate number of frost days using ERA5 daily data that is available. First, if you check the description here based on the reference, the number of frost days refers to annual count of days when daily minimum temperature is below or lower than 0 degrees Celsius. And now I'm gonna show you how to calculate actually this index using Google Earth Engine platform, and I will show you different scenarios for one single image calculation only for 1 year or for a couple of years together. Yeah, this could be very interesting tutorial, and suggesting you to follow and share it with other other actually researchers in the earth science and remote sensing community. First of all, go to search places on dataset, try to find ERA5 ERA5 daily product. ERA5 daily product is available. Daily aggregate is available here. If you go to the data description here, you will see this data is available since 1979. And if you go to the bands here, you can see the minimum and maximum air temperature with Kelvin format is available here with 27 kilometer as a spatial resolution. This is a good option for frost days calculation in a global and national scale. So first, import it into the code as an image collection, as you can see, and no need to select your region of interest first. First, I'm going to show you how to calculate this index for whole of the world. So first of all, make a new variable for ERA5 data equals to image collection. Here I'm assigning image collection to ERA variable, and then we want to actually filter our data based on a period of time, for example, time start and time end. Here, time start and time end are two variables explaining the period of time in which we want to calculate the number of frost days. First of all, I'm going to calculate number of frost days only for 1 year. For example, here, I'm going to start from 2018 to 2020. Time start equals to Earth Engine date. Allows us to actually convert a string format to the date format. So here Earth Engine date 2018, and then I'm gonna have time end here Earth Engine end date again. This time the end will be 2019, as you can see here. So if you print the ERA in the right panel, after a few moments you will have an image collection with 365 elements. But before go further, you must select the target band that here is minimum daily temperature. Here, as you can see, the minimum 2 meter air temperature is the target band. Just copy and paste it into the code. As I told you, as I mentioned in the previous tutorial, you know that whenever you want to select a target band, select is the function allows you to select this. For example, my target band is minimum 2 meter air temperature that will be selected using the select function. So if you run a code again you will have 365 elements here, but this time for each date you will have one element including minimum 2 meter air temperature, and here you will have some data description or some metadata information that allows you to make different filters based on, but not necessarily in this tutorial because we want to consider whole of the year and calculate only the number of frost days. So we don't need to make extra filters in this regard. And also we don't want to use actually that filter bound here, because we are working with era 5 products, that is coarse spatial resolution without framing structure. That's without framing structure such as Landsat and Sentinel. So now in the next step, I'm gonna actually calculate the number of days in which minimum temperature is less than 0 degrees Celsius. As you saw earlier, the minimum daily temperature already called for 2018, and now we need to make a loop structure to calculate to select the pixels in which temperature is less than 0. So it's very simple. For example, here a new variable as a frost equals to get error data first, and then make a loop structure using the map. To do the calculation, we need a function. Each input image to the function named as img, or you can pick any other names that you prefer here. So the function return that image. Actually, remember that the temperature image we are working with, their temperature unit, the temperature's unit is based on the Kelvin, but the index is based on the degree Celsius. That's why we need to convert. We need to have a conversion from Kelvin to degree Celsius. When your data is in Kelvin, there is a simple constant value allows you to actually convert it from degree Celsius, from Kelvin to degree Celsius. It is dot subtract a constant value that is 257.15. This is a constant value, allows us to do conversion between Kelvin and degree Celsius, as you can see here. And then I want to actually make a binary image in which pixels with a temperature below the 0 degrees Celsius will have number 1, and the rest of the pixels will have value number 0. So here the less than function allows me to do this. The less than 0. The pixels in which temperature is less than 0 will be 1, and the other pixels will have number 0. So now if I get the sum for the whole of the year, definitely I can show or highlight the number of days in which the temperature for each pixel was below or were below the 0 degrees Celsius. So if you want to see the results and understand how the results will be, map.add_layer is a popular function for the visualization. Here we will have the forest, that is, if you want to clip it based on a region of interest, it is also very simple thing. Let me to select a country. For example, one of the Nordic countries could be an interesting case for this study. For example, Finland is one of the Nordic countries, and here through the marker and here through the search places and dataset, you can call FAO administrative layer borders. That is very useful to actually define the border of region of interest based on administrative units. As you can see, the country boundaries that is already simplified is available. That could be a good option for this tutorial. So import it into the code as a table, and now you can actually see, through the map.add layer, you can see what is available in this table layer. Map.add layer, just for table, click on run the code, and here, as you can see, administrative layer for boundaries is available here, and easily you can filter your region of interest using a simple geometry through drawing tools we have here. For example, just I marked Finland just like that, and then make a new layer based on ROI equals to, I'm gonna filter the table or administrative layer based on the region or point that is selected by the geometry or the marker I showed you a moment ago. So Now again, I'm gonna have a map.add layer, and here first I'm gonna have focus on the study area through the map.center object, and then I'm gonna focus on I'm gonna show the layer of the Finland, the border of the Finland through the map.add layer here. If you run a code after a few moments through the Google map here, you can see we have a Finland border as the region of interest. And now in the next step, I'm gonna actually show the number of frost days for 2018 based on Finland border. So use map.add layer. Actually, the map.add layer is a function allows us to do the visualization for this product. Map.add layer, there are a couple of arguments. If you want to see the arguments and the rest of the code while you are typing, it is very easy to press command. It is very easy to press Control and space. So Earth engine.object, instead of object, I'm gonna show the frost layer that is already clipped based on a region of interest, and visualization parameters, leave them empty for now, and the layer name will be frost for 2018, and leave this shown as false because I'm gonna actually avoid automatic visualization that highly reduces the speed of processing. It is better to actually check when you want to show the show the final result. That's highly helped you to speed up the processing. Save the code first and then click on run. After a few moments, you will have a new layer here, frost for 2018, that allows you to see the layers. This is frost for 2018. Focus on a study area, and after a few moments you can see the frost layer, or you can increase the contrast through the 90% of values that is detected in the image. As you can see, the minimum and maximum value shows the number of days actually in which temperature was below 0 degrees Celsius. Click on apply, and here, as it is expected, we have a gray scale layer. The lighter or white region shows higher number of frost days, and also in the south we have higher temperature, and as we expected, the number of frost days will be lower than the north. With the darker color, you can see if you switch to inspector and click on each pixel here, easily you can see the number of frost days for each pixel. For example, the selected pixel had 161, and also if you go toward the north, you will see that the number of frost days is increasing clearly. Now imagine that we want to actually make a loop structure to do this calculation for each year separately. That could be an interesting option. But before go through this, let me to show you how you can get export from this image, because this is one of the typical questions that most of the users asking me, and also the people always worry about their calculations and they want to get export as soon as possible. There is no problem here, just you must make export that image that to drive allows you to calculate the to export the output. A couple of arguments should be considered here. First, the image you want to get export, that is frost that's clipped based on the Finland border or ROI, and the output layer name could be, for example, Finland frost for 2018, and a scale for the output should be equals to 27,000 meter, because the spatial resolution is to 27 kilometer, and the region of interest or geometry that we want to get export based on is the ROI already defined here, and the CRS, the coordinate system, should be EPSG 4326. This is the unique code that you can use for WGS84 coordinate system. This is the global code that you can use for everywhere you are working. And also you can use this tutorial for all around the world, and and also you don't need to limit yourself to only the location I'm working on. You can pick another location for your own country and also use the code for that easily. So I'm suggesting you actually to try this code for different region of interest to get more understanding about the programming techniques or scripting techniques in the Google Earth Engine platform. So there are some other arguments. The first was image, description, scale, region, and also the CRS. And also you can make a folder in your Google Drive to actually that allows you to save your data in. For example, I'm gonna make a folder as test to save the output there. And also if everything is fine, click on save and run it again. But when you want to get export from one image, just switch to the task just like this. And here, as you can see, the Finland forest is available here. Click on run, and after a few moments, you will have a new box pop up here, and click on run, and then the process of saving will be started in the Google Drive. So, as you can see, the process is going to start. If you had any question or problem regarding to this tutorial, you can reach me out on YouTube channel and share your comments. So here, as you can see, the process of saving already started. Once the data saved completely, oh yes, you can see that there is a problem here. You must convert the image to the floating point structure. This is very simple. Just add a float function at the end and click on run. And after a few moments, again, you can try for save. Click on run again. You can see it's started again. Once the process of saving completed, the tabs color turned to the blue, and then you can pick the file from the Google Drive and open it up in your desktop software. So such as QGIS, ArcGIS, the output will have TIFF format and can be opened up in all the geospatial software that you are using on your desktop system. Okay, now you get enough understanding about the number of frost days and its calculation or the methods for the calculation. Now I'm gonna show you how to make a loop for example 40 years and calculate the number of frost days for each year separately. Let's make a new time start and time end, because I'm gonna make a list actually to filter data for each year separately. In the previous example, the time start and time end limited to only 1 year. And the new time start and time end I'm gonna create will have a longer period of time. And also, as you can see, the Finland forest is saved completely and you can pick it up from your Google Drive now. So back to the tutorial. Now let's make a new system time start equals to starting from, for example, 1980, for example, and the time end, the new time end equals to Earth Engine dates 2020, for example. If 40 years period is considered in this tutorial, I'm gonna see that how actually number of snowy days varies in the Finland for over 40 years. That could be very interesting research questions that or kind of the data or information that's about the interaction between climate or climate change could be considered in each studies, specifically for the Nordic region. So then I'm going to calculate the number of the number of years do we have between time start and time end. Here, another variable as time difference equals. Using difference function, I can calculate the differences between time end and time start. If you press on control and space here, you can see we have two arguments. One of them is a start that could be actually equals to that is equals to the time end. The time start, It was my mistake because the difference uses the time end and time start. First time end counts and then the time start, and the unit will be based on a year. This is a typical method that I used in the most of the tutorials on my YouTube channel, and it is really easy to understanding. Just you must keep trying and learning about the Earth engine basic materials, and then writing such kind of the codes could be very easy for you, because the Earth engine developed for non-programmers. Almost all of the Earth engine users are scientists and researchers in earth science, environmental engineering, and fields related to the earth science, and none of us are programmers. Just we are using scripts and actually using scripts to make the batch processing for get final results. That's why scripting in the Earth engine is very easy, and just you must have a little try and error for each part of your work to learn more and more. Here we have the time difference. So let me to calculate the number of time difference, the number of years we have from time end to time start. As you can see, the output is has a float structure, but we must round it to the integer format. As you can see, the 40 is the number of difference, number of years we have from time end to time start here. Now I'm gonna make a list with 40 rows based on the number of time differences, or based on number of the years. Here we want to have a list here, Earth engine, that's list, that's sequence. So the list of sequence including couple of arguments, the list starting from 0 and ends to the number of years as a time difference we had. As we are starting from 0, the time difference should be actually subtracted from 1, because otherwise we will have 41 record instead of the 40. So the step will be 1, because we want to calculate for each year separately, for after 1 year to another year, from 1 year to another year. So skip the count and now make a print, get a print from the list to get more understanding about the list situation. So that subtract 1. Yes, now the problem is solved. As you can see, we have a list with 40 elements starting from 0 to 39. Here we have 40 elements starting from 0 to 39 based on the differences and parameters we already settled for the list.sequence. So now I'm gonna have the year value or the date of each year separately instead of actually the simple numbers. So to do this, make a loop structure and then make a function. Each number is the interval explaining, is an interval number explaining the time differences from start year to from origin year. So here the input value could consider it as interval here, and finally the loop structure and function returning each row with its date here. So return from origin date time start. We must go advance or we must go forward based on the delta that it is already defined through the interval that you can see here. So here the interval and the unit will be year. For example, the number 15, meaning that the value for number 15 is a year, for example, 15 years after or 15 years after the origin date. The origin date is 1980. The number 15 will be 15 years after 1980. So that shows how the code is working. So run a code again, and this time you will have a list of years starting from 1980 to 2019. As you can see, the row number 15 shows the year 1995. That's actually exactly expressing the relationship between interval and also the time start. So here we have the time starts already defined in the list, and now we must have another date as a time end for each year separately, then we can actually filter the era 5 data based on its new start year and end date in a loop structure. So make another variable here. For example, another variable here could be uh, frost frost collection, for example, because we want to have an image collection, annual image collection that shows the number of frost days for each year separately in each pixel. So the output should have an image collection format. That's why Earth Engine.image collection is necessary and then we can bring the list inside the image collection, make a loop structure based on the loop. The list already included the dates, but here we should make a new variable as a start date that explaining the number of explaining the start date. Actually, the date we have here, these are the start dates. Here, a start date equals to the date or input date, and then the end date equals to, now from we have a start date. From a start date, if we go forward based on 1 year interval, then the end date will be introduced in the code. From start date, we must go forward, that's advance, through the advance based on a delta. The delta will be 1 and the unit will be year, and skip the time zone. Now the end date and start date created in a loop structure. When the code runs here, for each time start and time end, we can filter the era 5 data. Here, another variable as filtered image equals to the filtered data equals to get era 5 data. So here the era 5 data already known with the image collection in the code, and the target band was the minimum and the target band was the minimum 2-meter air temperature data, as you can see here, and the data, the target band is selected, and now we can filter our data based on each year through the start date and end date easily. So now after after filtering our data for each year separately, now we can make a loop structure for images for each year. So each input image here entered into the function, and the function returned the number of days in which temperature were less than 0 degrees Celsius. First, we must subtract it from a constant value to convert Kelvin to degrees Celsius, and then select the pixels with temperature lower than 0 degrees Celsius. Now for each year, the number of frost days calculated through the sum, because we already had a binary image for each date in which number 1 shows the frost, shows the pixels in which temperature is less than 0, and then using the sum function, the number of ones or the number of frost occurrence or number of low temperature occurrence will be calculated here. So, and finally, the whole function frost collection returns the filtered data with a new system time start, because the frequency of data changed from daily to annually. Now we need a new system time start. That's why that set allows you to make a new system time start. System time start equals to start date, just like that. That's millisecond format. And then we want to have another properties as a system index that shows the date of each image with the normal format. Start date with the normal format. Just format based on this structure: year, month, and day. So get a print from frost collection to get a better understanding about the products we created here. As you can see in the right panel, instead of a list with 40 elements here, you will have an image collection with 40 elements or 40 images, all of them including a band that shows, and also you can change its name to the frost days. Frost days. If you run a code this time, you can see the band names as a frost days here. Yes, this is the frost days calculated, and in the properties you can see the system index and system time start. System time start explaining the system index with the actually millisecond format, because it is necessary in the Earth engine to have millisecond structure for the time series analysis. Now easily I can make a plot to shows number of frost days, average of number of frost days in the whole of Finland over the last 40 years. Here, just make a print, user interface, chart image, that series here. As you can see, instead of image collection, we will have a frost collection, and the region will be ROI or Finland. And now I'm gonna get average of frost days, Earth engine.reducer.min. Actually, the reducers is reducers are functions that allows us to call different statistical operators. And the scale will be to 27,000 because the spatial resolution is 27 kilometer and 27,000 meter, I mean here. And X properties will be system time start. We already discussed how to calculate the number of the system time start for each image separately. So after a few moments, you can see, as you can see here, this is the number of frost days variation from 1980s to 2019. And as you can see, the vertical axis shows the number of days for each year separately. That maximum will be 365, because for each year we have 365 days. So here it is. As you can see, there is a very slight or gentle decreasing trend here. As you can see, specifically after 2000, the average number of frost days varies in this region. And also you can calculate it for any regions in the world, or you can calculate it for based on the basin border, based on a point location. It's totally up to you how to use this output. And remember that if you want to get export from images for each year, first let me show you a visual characteristic using map.add layer here, and then I will show you how to get export from this layer. So a couple of arguments we have here. The first object is the frost collection. If you want to see all images together, you must integrate or you must actually bring them into a single layer stack. So here that two bands help me to do this, and then clip it based on your region of interest. Leave the visualization parameters empty, and the layer name will be frost days collection, just like that, and leave the shown as false to avoid automatic visualization. Run a code again. After a few moments, if you go to the layer setting, you will have a new layer, as you can see here, frost days collection. So click on frost days collection. You can go to the layer setting and select the target year. For example, 2000 is my target year, and then increase the contrast by 90% of values in this image. Click on apply, and here you can see the variations easily. So here the number of frost days in the northern and southern Finland have shown clearly. So, and you can check different years if you want, and also you can get export from this output easily from this result For example, again, let me to call export.image to drive, but this time we need to have a little changes. So here export.image to drive, same function, but we need to run it for another result. It is a frost collection that is stacked through the two bands. When you have an image collection and you want to get export, it is necessary to make it as a to actually bring it into a stack layer structure using those two bands, and then clip it based on the region of interest, turn it to the float structure, and here you can change the output name, and the rest of parameters should be same. Just save the code and run it again. If you switch to the task here, you will have a new output ready for saving, and this is Finland Frost Years. Click on run, a box popped up same as before. Click on run again. Now after a few moments, the process of saving starts, and once the tabs color turn to the blue, meaning that you can pick it up from your Google Drive. I hope you liked this tutorial, and if you had any problem regarding to the code, it should be noted that the code link is available below the video below the video on my YouTube channel. In the description box, you can pick it up from there and compare yours with mine, and then find the potential errors. If you have if problems still exist, again, you can reach me out on YouTube channel and put your comments there. Thank you for your attention.